Hi there. If the following free content proves to be useful to you, please consider liking the video, subscribing, and checking out the pinned comment down below for more options to support my efforts. Thank you for watching, and please enjoy the video. Alright, so Zleifer says, I'd like to get... Sorry, one sec. Zleifer is asking, I'd like to get started with design patterns. Could you recommend a book or resource? I'm kind of rephrasing his question a little bit. Now, so what I'm going to do is, before I answer your questions, Zleifer, I'd just love to give any beginners watching a basic idea of what design patterns are. So now, before I continue, just be aware that the way that I'm going to explain a design pattern might be really different from how academics, people in computer science, might explain it. And that's because I learned them by building applications. I do have a good textbook, which I love, on design patterns, which I'll share with you. But yeah, my explanation might be a little bit different from the average one. So what is a design pattern? And this is a really wonderful sort of thing to get started with here. Okay, so a design pattern. So when you're building a software application, you have this thing that's sort of called the problem domain. And how I would describe that is, so I have to go to a practical example. Let's say we're building a note-taking application, just a note app. So in applications which have like an end user, someone using the thing, you've got someone interacting with it, and then you've got like your sort of framework, which would be like the Android operating system and stuff like that. And then because you're working with a note-taking app, you just kind of know that you're going to have to be saving data. So right off the bat, we've got these things that we know we will need to build a software application. So for example, in my recycler view, my new recycler view tutorial, I shared with people just a really basic application architecture design. I'll just hold it up right now. And basically what this is I'm drawing the classes and the architecture of the application. And this is something that is really useful for me, because what this allows me to do is, once I sort of get a rough sketch on paper, then I can think about it in my head, and it becomes very easy for me to think about software architecture. So how does this relate to design patterns? Well, it turns out that this problem domain, the things that our app must do in order for it to satisfy its description, the things that a note-taking app must do is it must take notes, it must take user input, it must sort of kind of manipulate that input, and it must be able to save it and things of that nature. The point I'm trying to get at is almost every application you will build, and this is particularly true of applications outside of like computer science, practical applications, they almost always look the same or very similar from an architectural standpoint. For example, the Recycler View app has 3 layers. It's got a visual layer, it's got a logic layer, and it's got a data layer. So how design patterns work is it turns out that when you're building these things, you will tend to run into problems or things you need to solve, which really, really smart people have already thought a lot about. So knowing that, developers have started to developers have created these things called design patterns. So my favorite design pattern, which I would like to share with you, and it's one of the most basic one. Do I have, I'm just trying to think. My favorite one is, let me just pull it up here. So Zleifer, to answer your question, a book which I really like, which was recommended to me from a friend of mine who's a good Java developer, is called Design Patterns Explained. I am not paid to say this. I just really like this book. Now, if you're a beginner, I don't know if you are, Zleifer in particular, but for beginners listening, this can be fairly intense stuff when you're just starting with it. It's complicated. It needs good explanation. Now let me share with you a basic design pattern, because I can babble about it and use words all day, but the best thing to do is to show you pictures, because design patterns translate very well to architecture. Like, let's say you were designing a building. So my favorite design pattern, which I'll just show you really quickly, is what this book calls the facade pattern. So I'll just show you the picture, and what I want you to notice is that you've got like a bunch of classes in this box kind of talking to each other. Oops. And then you've got this interface talking to these things out here. Now you might be wondering, you might be thinking like, Ryan, you're just pointing at a bunch of like empty boxes and one of them has the word interface. What does that have to do with building applications? Sit back and I'll explain. Okay. So let's open up I'm going to open up my Recycler View repository here. And what I'm going to do is I'm going to open up the controller. And what I would like you to notice is that this controller object, let's not worry too much about what it is, just know that it makes decisions. It's a logic center. It's the logic center of the app. It talks to a data source through an interface. Again, what it says right there, interface. I want you to think that the controller and the view, the visual part of the app, the Android stuff, model view presenter, controller kind of thing, is that stuff there. And then we have this interface, and then we've got these things out here. That is exactly what's going on in my code. This controller is talking to an interface. It's not talking to a specific concrete object. Why is that important? Well, let me give you a very practical understanding of why this is important, because it's really key. Did I switch back? Yep. So I don't actually know, here's the funny thing, I don't know what this thing's going to talk to by looking at this controller class, because it's just an interface. An interface doesn't have any implementation. Well, let me show you what concrete class this controller currently talks to, which is fake data source. Excuse me. And I want you to notice very specifically that this fake data source implements the data source interface. it implements the thing that this controller talks to, but the controller doesn't know that this is a fake data source. Why is that important? With the facade pattern, which is this thing, with the facade pattern, or sometimes I've seen it called the repository pattern, the rest of the app, the controller, the activity, all that stuff, it doesn't need to know or care whether it's talking to a fake test database, a Realm database, or an SQL database. I'm just making this up. I'm not saying these are specific things, but because this interface sort of acts as a boundary, the rest of the app can talk to any of these things as long as they respect the interface. So what's a practical thing? Let's say I was building an application like Facebook. I would want to have a local database, a local data source to store things temporarily. And then I would also want to have a remote database or a remote service that my app talks to. With the facade pattern, I can talk to different kinds of databases. It could be Realm, it could be SQL, it could be a REST service, all through the same interface. So hopefully you can kind of wrap your head around how important that is. It'll become more obvious later on when you start building these things. So that is basically an example of a design pattern. It's a problem which has been solved already, and it just makes sense to talk to these things through one interface. So hopefully I kind of explained. So I'm just going to write a definition of the design pattern, and then I'll talk a little bit more about resources. So a design pattern, when building applications, you'll tend to run into the same problems as pretty much any other application which you or any other developer must when building applications, you'll tend to run into the same problems as pretty much any other application you'll build. The problems will be, when building applications, you'll tend to run into the same problems. You'll tend to run into the same problems. It turns out that certain solutions to these problems are tried, true, and tested. These solutions or approaches are commonly referred to as design patterns. Sometimes these terms can get conflated or confused with other things like software architectures, sometimes referred to as software architecture patterns. And the thing you need to realize is that what really separates software architecture and patterns and all these different things is not a lot. It turns out that if you build apps in specific ways, if you follow software architecture patterns, to confuse things more, really what you're doing is you're building things in a way that solve the problem really well. So hopefully I've kind of given a decent overview or like a practical explanation of design patterns. Design patterns in software architecture are basically my favorite topic in software development. It's something that for I guess like genetic reasons, it's very easy for me to visualize software talking to each other and things like that. So it's an area of great personal interest to me, and when I'm more confident with it, and I'm already quite confident with it because I've been working with it a lot, I will be making extensive material on design patterns, on software architectures, on all that stuff, because I love it. And to finish this question off, the thing that is really cool about following design patterns and building your software to architecture is that it solves problems before they become problems. It's so hard to describe, but the way, if you build things in a way that makes sense, then problems which you normally would run into without following architectures and design patterns disappear, and solutions start to just appear. So the last thing I'll say is to give you a practical metaphor for software architecture and design patterns in really simple terms that I think will help you understand why this stuff is important. Let's just pretend that we are designing a house, just a basic house. Let me ask you, let's say we've got a particular part of this blueprint that we're designing, and it might even look kind of similar to that. We're designing blueprints, and this particular part of the blueprint we're building is called a kitchen. Let me ask you, does it make sense to put a toilet in the kitchen? Does it make sense to put a grill in your bedroom? No, it doesn't. And there are ways that you can design a house that make sense. And those ways can really be arrived at through experience and common sense. It's the same thing with software. Why do I divide my applications into layers? Like, where's my big, do I have my big architecture thing here? I don't know if I do, unfortunately, but whatever. Why does it make sense to divide things into layers? Well, it turns out that if you've got a class or a layer of your architecture which is responsible for logic and decision making, it probably shouldn't also be responsible for storing data. If you've got your activities or your view, your visual stuff, it most certainly should not be responsible for saving data. You can do everything in one huge activity. It's just a really stupid thing to do that will create a ton of problems for you. That's that.